Chapter 4, Chemical Reactions, Chemical Quantities. And here we have a quote from Linus Pauling. I feel sorry for people who don't know anything about chemistry. They are missing an important source of happiness. Many of you might disagree with that, but that's okay. So, this first section, talk a little bit about climate change and fossil fuel combustion, just as a tie between what we're doing in class and things that actually matter in the real world. So, as you hopefully know from your science classes, here we have the Earth, and we've got this layer of greenhouse gases, and they're called greenhouse gases because they act like a greenhouse, and they trap the energy from the sun and help to keep the Earth warm. We need a balance of energy coming in and energy going out to maintain the temperature. If the greenhouse gases are too thick, it'll get too hot here. If they're too thin, it's going to get too cold. So, as with most things in life, balance is the important thing. Now, this is old data, but it's been in the news a lot. So, scientists have measured an average 0.7 degrees Celsius rise in atmospheric temperature since 1860. And they've also observed the atmospheric CO2 levels, which is a greenhouse gas, has risen 38%. So if you look at graphs here, this is carbon dioxide concentration in parts per million from the 1800s up to the late 2000s. And here's the temperature deviations in that same time period. We see that there seems to be a very similar trend, right? The question is, are the two trends causal? Is one causing the other, or are they just happening at the same time? And that's something that can be very difficult to figure out. We also need to be careful when we look at graphs because the way a graph is scaled can make it look more or less alarming than it necessarily should be. So here we're looking at tenths of a degree of change in overall temperature. The blue parts are an average of the year, and the red line is a 5-year average. So that's a little more reliable than the year to year because we have hot years and cold years.
I see the carbon reduction in what, over one-ish.
No, okay. So where does CO2 come from? Well, of course, the one that we're most aware of is combustion of fossil fuels. Gasoline, coal, oil, different things like that. We use those to get energy. Another source of CO2 is from volcanoes. Volcanoes are natural, and they are spewing CO2 into the atmosphere as well. So how can we see whether global warming may be natural? Maybe this increase in CO2 is from volcanoes, or is it due to our use of fossil fuels? So we need to understand how the chemical equations describing fossil fuel combustion relate the amount of fossil fuel burned to the amount of carbon dioxide produced. And this can help us to tell, well, is the amount of CO2 from all of this combustion a bigger factor than the volcanoes or a smaller? And we can use chemistry to figure that out.